Welcome to qnawire.
All right, let's go ahead and solve this problem. So as usual, we are asked to evaluate this double integral of curl f dot ds. Okay, it's probably not the best idea to do this straightforwardly because, as you can see, f is already quite involving. You have you have xy, xz, a bunch of cross terms. So the curl of that expression is not going to look anything simple. And the surface is an ellipsoid, which makes things a little bit even more complicated. However, using Stokes' theorem, we can simplify this problem significantly. So let's take a look at what it says. First, we're going to be able to say that this is equal to a single integral of through c of f dot dr, so it's a line integral. Okay, so we want to be able to figure out what c is as a projection, and then we want to basically parameterize that so we can do the calculation. All right, so the ellipsoid is right here. You can find out that y is from 0 to 4, and the projection onto the xz plane is simply a circle. So C is a circle. X squared plus Z squared is equal to 1. Okay, so because of that, I would like to choose the parameterization. X equals to cosine theta. We know that Y is equal to 0, and Z is equal to sine theta. Okay, now when we take a look at the f in terms of the parameterization, we know that y is equal to 0, so e to the xy is simply equal to e to the 0, or in other words, 1. Xz is e to the cosine theta sine theta. It's a little bit alarming, but don't worry. And x squared times z is equal to cosine squared times sine. Okay, so let's calculate what f dot dr is equal to. To calculate that, we simply needed the r prime. So r, the partial derivative with respect to theta, will simply be negative sine theta, comma 0, comma cosine theta. So f dot r prime, that is equal to negative sine theta. And fortunately, e to the cosine theta sine theta times 0, that one disappears, so we don't have to worry about that. And the last expression is cosine cubed theta sine theta. Okay, so all we have to do is to evaluate this thing. So it is an integration. We already found the parameter of theta. It's from 0 to 2 pi. It's one entire revolution. And I can factor out a sign just for simpler notation. Cosine cubed theta minus 1 d theta. Okay, now this is quite a straightforward integration, so I will leave it up to you to do the rest of the calculation, but this simplifies to 0. So I want you to confirm that on your own, but in the big picture, this is how you use Stokes' theorem to solve this problem.